And the last three on this page is simplifying when you have a higher exponent. And so what they're going to do is have you rewrite it in terms of I squared so that you can substitute in -1. And so they're going to first of all take 2 and divide it into 35 using the long division with the remainder like we did way back in, I don't know, 3rd grade probably. So 2 goes into 35 how many times?
1. Oh, 35.
1.
I was thinking just 3.
And then 2 goes into, yep, 15. 7. And we get a remainder of 1. Yeah, we probably would have did it the long way when we were way back in grade school. So we would write it as I squared to the 17th power times an extra I. This would be 34 plus 1 more is 35. I squared then is -1, and when you take -1 to an odd power, it's going to stay -1, right? -1 to an even power becomes +1, but this stays -1. -1 times I gives me -I for my answer then. There's only ever going to be 4 possible solutions. You're either going to get I, -I, 1, or -1. Anything other than that is not going to be correct. So if I have I to the 24th power, I can write it as I squared to what power? The 12th. This 2 goes into 24 12 times with no remainder. I squared again is -1, and if you do -1 to the 12th power, you get +1. So 1 is just going to be my answer. So 18, we're going to write it as I squared to 26. That gives me 52, so I need that extra I on the end to get to my 53, right? I squared to the 26th power. -1 to the 26th power is 1, and 1 times I just gives me I then for my answer. All right. It's probably as much as they're going to do with imaginary numbers.